right, so today we're going to look at section 12.4, the hyperbola. Okay, what is a hyperbola? Well, it is a set of all the points such that the difference of the distances from P to two fixed points called the foci is constant. So this time the distance D2 minus D1 is a constant for every single point on the hyperbola. The line through the foci intersects the hyperbola in two locations. So if I draw a line between these two, it intersects in two locations. Those two locations are called the vertices. The segment that joins them is called the transverse axis. And the midpoint is the center of the hyperbola. So right here in the middle is the center of the hyperbola. The hyperbola has two branches and two asymptotes. The asymptotes contain the diagonals of a rectangle centered at the hyperbola center. So if you look down here in these pictures, you can kind of see that the asymptotes and the rectangle centered at the center. So if the vertices are at A, then we find the B, and that gives me the box that goes around it. If I draw the diagonals, it will go through the center. And the hyperbolas, these are asymptotes of the hyperbola. So the hyperbola, as you know, the farther out I go, the closer it's going to get to that line. So in drawing these things, we're going to use this box to help us draw the asymptotes, which will help us draw the hyperbola. So let's take a look at this one. This one is easy to determine from the general form because one of the squared terms will be negative. Okay? Here the hyperbola opens right and left, or better yet, you can look at it as the transverse axis is horizontal. Okay? And over here, the transverse axis is vertical. So whichever one is positive tells you which direction the transverse axis is. So here y is positive, so it's going up and down. Here x is positive, so it's going right and left. Now, these numbers, A and B now, does not necessarily mean that A is the bigger number. This one is about which one's positive. Okay, because it doesn't have to follow the bigger one and all stuff. So you just make the box from A and B, and then the diagonals will help form your shape. Okay? So just keep that in mind. Whatever one is positive, that is where the vertices are going to go. Okay? X is positive, it's going to go horizontally, so A is horizontal. That's what those are. Whether it's bigger or smaller than B does not matter. Okay? And then, so this is what this is establishing for you down here. Notice in this particular case that C squared is now A squared plus B squared. So it's going to be basically like the Pythagorean theorem kind of idea. Okay? So, and you can kind of see it right here. See how you have a right triangle and all kind of stuff. But not necessarily for that reason. So here we have this right here. So let's take a look at some problems we can do. So one of the things we're going to ask you to do is determine what A and B are. Determine the transverse axis is horizontal or vertical. You want to find the vertices. We're going to draw the rectangle centered on the origin. We're going to draw the asymptotes, and then we're going to draw the hyperbola. Okay, so let's do that. Here we go. So just like the other one we did, I want this to be a 1, so I'm going to divide everything by 144. When I divide every term by 144 and reduce it, that equation right there becomes x squared over 16 minus y squared over 9 equals 1. It shows me that x is the positive, which I knew already, and that means this is A. And it also tells me that we're going to be going horizontally. So I know A is 4 and B is 3. Okay? So I know from this instance right here, there's the A and B. Is it horizontal or vertical? For part 2, I know that we are now horizontal because this x squared is the positive one. Where are my vertices going to be? The vertices are where A are, where A is, and so that means our vertices are going to be at the points plus or minus 4, 0. Okay, so we can put those out here at 4 and negative 4. B is 3, so that's going to be at 3 and negative 3. And these are the lengths for your box. So basically what you want to do is you just want to draw a dotted line all the way from here to here, all the way down. You're making a box just like this, centered at the origin. See, so you made that box. What I can do now is I can take my ruler and I can connect the corners of this box through the origin. Okay, and draw that as a dotted line. Because they are boundaries for the graph, they are not part of the graph. Draw that diagonal. Okay, so these are my two asymptotes. The equation for these things, since they go through the origin, you just need to know the slope, which is going to be rise over run. So it's going to be up 3 and over 4. So this is y equals up 3 over 4x. This one is the negative, so you're going to go down 3 and over 4. So this is y equals negative 3/4 x. And you're going to want to name those horizontal asymptotes for me. Okay? And so we know that it opens right or left because this is my transverse axis right here. And so that is the vertice. So it's going to be in between these things. So just kind of draw a nice smooth curve, getting closer to that. A nice smooth curve, getting closer to that. Do the same thing over here. Get closer to that. Oops. Okay, see what I'm doing? Get closer to that. Little arrows on the ends. So here's my vertice at 4, 0. Here it is over here at negative 4, 0. We can find C, the foci, because C squared is A squared plus B squared. That is A squared, that is B squared, so 16 plus 9, 25. So C is going to be at plus or minus 5, comma 0. 5, negative 5. So that is 5, 0, a foci, and this over here is negative 5, 0. So there is our hyperbola drawn. Draw the box, draw the diagonals, then draw the hyperbola. Okay? Down here, we're going to write an equation that has this information in it. Gave you the foci here and here. The vertices are here and here. You'll notice that the major stuff are on the y, which means it's going to be vertical, opening up and down, which means the y has to be positive. Okay? So it's going to be this one. And again, it doesn't matter what the number, the letters are. The bigger one can be anywhere, but it's going to be y squared over something, and then it's going to be x squared over something equals 1. Now, from here, these are A. Okay. I'm sorry, those are the foci. These are the number that's going to be squared. So this is your give 1 second. So this is going to be your A is at 3. Okay. C is 5. So using C squared equals A squared plus B squared, plugging these numbers in, we have 5 squared, 3 squared, B plus B squared. We can solve this out, and we literally get B squared is 25 minus 9, which is 16. So we can see that B squared is 16, so we don't need B. Okay, so we can put in our 3 squared here, which is 9, our B squared here, which is 16, here's the equation of our hyperbola. Okay, let's look at another question. So here's this one. A hyperbolic mirror can be used to take panoramic photographs. A camera is pointed toward the vertex of the mirror and is positioned so that the lens of one is on one focus of the mirror. A hyperbolic mirror has a cross section represented by this equation right here. How far is the mirror from the lens? So this is basically trying to figure out where the focus is. Okay, if this is the way it's written out here, it's centered at 0, 0. So we need to find the focus, which is c squared is a squared plus b squared. There's a squared, there's b squared. So c squared is 9 plus 25, or 34. So c is going to be at plus or minus the square root of 34. So how far is the lens from, how far is the mirror from the lens? Well, it's the distance of this. Now, I don't know which side it's on or anything like that, but this is the distance right here. So the mirror is the square root of 34 units from the lens. And that's how you can answer that question there. All right, down below is another question. On the coordinate grid here is a diagram of cross-section, hyperbolic cross-section of a large hourglass. We want to write an equation that models the curved side. So this is the hyperbola right here. We want to write an equation that models it. So we can see that it is horizontal. We have vertices at -2 and 2. Okay. And then we have, so that's A. So from this here, we can see that A so A is 2. Okay. We see up here that that distance is 36, or 6 from here to here, okay, from the center. And we know that since it's going this way, we know that we have an equation that's going to be x squared over a squared, which in this case will be 4, minus y squared over b squared equals 1. Okay? Now, what we want to do here is we want to look at this a little bit differently. We can't say necessarily that point is on a hyperbola that would be drawn here. Okay? So we want to look at it a little bit more closely. Let's see what's really going on here. So I know that this point is there. So we can take this point, okay, and we can plug it in here to find b using that technique. Okay, if I do that, what I'm going to find, let's plug it all in here and see. If x is 4 and y is 6, okay, then what I end up with is plug in the 4 here over 4, plug in the 6 in here, that's b squared equals 1. And then as I solve this for b squared, okay, so this right here is just going to be a 4. So this becomes 4, and then move that over and move that over. Minus 1 is 36 over b squared. And then I can do some other things and cross multiply and stuff and get an answer over here. So this becomes 3b squared is 36, and so b squared is 12. And I get x squared over 4 minus y squared over 12 equals 1. So that would be the equation of the hyperbola. Okay? The next part here is, well, what happens if at the height of 7 inches? So what if we made this bigger? Okay, what if I drew a line across the top here at 7? What we want to do is we want to find out how high it's going to be. Okay, so we can take that information that we have, this equation, and we plug in a height for 7. Oops, I put an equal sign there. This will be a minus. And this will be 7 squared over 12 equals 1. And then I can go through the process here of solving this thing. If I multiply everything by 12, what I get is 3x squared minus 49 is 12. Move some things around. This will be 61. Divide by 3. And I'll get square rooted. X is going to be approximately 4.509. Oh, you can't see that. But that's only half the distance. Okay? So we have to double it to get the other half. So we want to know the whole top. So it's this distance and then that plus that distance. So it's twice that thing right there. And so our width is going to be twice that. And if you times that by 2, you're going to get 9.018. And so that is a way you can do some problems associated with hyperbolas. And we will do more problems together in class. And that ends this video.